everybody. We are going to talk about our final 2 classes of organic compounds today, April 27th. These are the amines and the amides. Okay, so we will start with the amines. And the importance of amines are that they are used for the creation of amino acids, the building blocks of proteins. So hopefully this sounds quite familiar to you from your days back in the living environment. Please be aware, and this is actually true for most of the organic compounds we've been naming, we will be looking at only a few examples of naming amines and amides, and just be aware that they are consistent naming protocols with table R. There are other ways to name organic compounds. We're keeping it pretty simple by using our favorite cheat sheet, table R. Okay, so we're looking at the bottom 2 rows here. Let's talk about amines first. It's a first thing, by the way, nitrogen. This is the first time we are seeing nitrogen involved with these organic compounds as part of the functional group. So that's really important. And in fact, you'll see that with the amides as well. The minute you see nitrogen, it's either an amine or an amide. So let's look a little more closely here. We'll look at our first example of 1-propanamine. Okay, so I've copied the condensed formula here. I'll write that out fully for you because this is how you're going to be successful on Regents questions. When you can take that condensed formula and write it out fully to see that structural formula, you will very likely be able to name or at least identify what group or class of organic compounds a molecule belongs to. So if we look very carefully here, we've taken the condensed formula, we've written the structural formula. We are told it is 1-propanamine. We always go back to that parent backbone. Propan refers to 3-carbon backbone. Amine is the functional group. So this is our amine group, making 1-propanamine. Let's look at 2 more examples. Notice I've drawn the amine group over here on the left. This one I happen to have it on the right. It doesn't matter, but in this case, it's only 1 carbon. So we're going to call that methanamine. And we don't have to indicate where that amine group is because there's only 1 carbon. And even this compound with 2 carbons attached to the amine, we're going to call that ethanamine. It does not matter which end I put that amine on, it's still considered the first carbon. So that would be the proper naming using this method. Now, just a quick note that amines can be used to make very important compounds for living organisms. And I just wanted to give you the general structure of an amino acid. You are not going to find this on table R. That means you're not going to be expected to know this or to recall how to make this structural formula. So I just wanted to show you, though, how that is breaking down here. Here is that amine group. That is the functional group for this class of compounds. But I hope you're recognizing this carboxyl group from the organic acids. There's that carboxyl group, and we end up with an amino acid, and this would be the general structural formula for them, and that R is some variable. Amine functional group, carboxyl functional group, okay? And amino acids link up to form polymers known as proteins. And we will talk about that in our lesson tomorrow. Okay, I'm going to move on to our last class of organic compounds, the amides. As a reminder, these also have nitrogen associated with them, so just be aware of that. The uses of amides are quite varied. They can be found in pharmaceuticals, they can be found in various materials such as Kevlar and nylon. And let's look at an example. The example, again, is coming from Table R, our condensed formula. I will write that out. Okay, so if we carefully look at this, the amides are a little more complicated because they have an amine group here. But, ooh, they also have a group that hopefully looks a little familiar to you as well, the carbonyl group. Carbonyl and amine group. And actually, this bond between that carbon and nitrogen, the carbon of a carbonyl and the nitrogen of an amine, is called the amide group, okay? Making this an amide. So this is the functional group here, linking these two. And when we look at our example, this is called propanamide. Why? Because we have the 3-carbon backbone, propanamide. And that is one example. I'll give you 2 more very basic examples of amides. You'll notice we only have 1 carbon in this, so it is methanamide, carbonyl group, amino group, amide group with 1 carbon. The 2 carbon, you're right. Ethanamide would be that example. And to conclude this mini lesson, I always like to go and show my ball and stick models. You know, you guys, I'm going to miss these when organic chemistry is over. And it is going to be over in 1 more lesson, believe it or not. But here's our 1 propanamine. If we look carefully, we've got some length of a carbon backbone. In this case, 3 carbons, propan. And the amine group is that nitrogen with 2 hydrogens here. And it's located on the 1st carbon, so it's 1 propanamine. Let's look at our amide example from Table R. Propanamide has a 3-carbon backbone. Here's that carbonyl group, the double bond to an oxygen. And here is that amine group. These together make the amide. Amines and amides. That's it. Have a great day. Bye.